Hello. Yes. We welcome you back to PSSB, Physical Sciences Silver Bullet. And the name behind the channel is Richard. We would like you to subscribe if you haven't, and we urge you to interact with us. Okay, today we are looking at this question. It says, consider the flow chart below. It's a very simple one. We are having B changing into C. That's where the arrow goes. And the B changing into A. And we know that C is an alkene. And here A is a bromoalkane. Now the first question comes, what does it say? It says, write the name and the chemical formula of the inorganic compound X. So this is our X. X is used to execute a change from alcohol to alkene. Okay. What compound do we use there? Okay. The compound is, if it's the name, the compound is sulfuric acid or sulfuric acid. And the chemical formula is H2SO4. That's the compound. To change an alcohol to alkene, we use sulfuric acid, conc sulfuric acid. Concentrated sulfuric acid. Okay, let's go to the next question. Then comes this question. It says, what is the function of the inorganic compound X named in 1.1 above? So we know that the inorganic compound is sulfuric acid. Now the question is, what is the function of sulfuric acid in this case? Okay, we are going to look at this case in details. That's why I don't want to divulge much about it. But what we are seeing here, the reaction is called dehydration. It's a kind of elimination, and the kind of elimination of the type dehydration, removal of water. So what does the sulfuric acid do in the removal of water? It becomes the dehydrating agent. So what is the function? It acts as a dehydrating agent. So that's the function. Let's go to the next question. Then comes this question. It says, name the type of reaction 1 taking place to produce alkene. So this is our reaction 1, where alcohol is converted into alkene. What is the name given to that type of reaction? Here 2 names are acceptable. 1, it is an elimination reaction. Okay, What type of elimination? It is dehydration. So both names are acceptable in this case. And let's go and see what happens to the next question. Then comes this question 1.4. It says, briefly explain how you can confirm the presence of alkene. Remember, we know that alkene is one of the product, yes. Being formed from alcohol, yes. The reaction is elimination, yes. What type of elimination is dehydration? But now comes this question. How do you confirm that an alkene actually has been formed? This one is tantamount to testing for alkene. How do you test for the presence of alkenes? Alkenes are brothers to alkynes. They belong to category of organic compounds called unsaturated. They are unsaturated compounds. And how do you test for unsaturated compounds? There are several ways, but the most straightforward is using bromine water. Unsaturated compounds decolorize bromine water immediately. The word immediately is very important because bromine water, on exposure to sunlight, it becomes colorless even without adding there anything. So the word immediately is very important. Let's go back to the question. How do we confirm presence of alkene? You add bromine water, and if it is decolorized immediately, then there is presence of alkenes. Thanks very much. So that is that. We say we add the bromine water. Bromine water is brown, and if it is decolorized immediately, then alkenes are present. Okay, let's go to the next question. Okay, then comes this question 1.6. It says, using condensed structure formula, write the equation of the reaction taking place to produce alkene from B. So they want us to write this reaction. Reaction 1. Okay. And they're telling us to use a structure formula, condensed structure formula. So what do we do? This is what we know. So you have your reactant, which is an alcohol. Okay. So what happens to this alcohol when you have sulfuric acid and you heat? Dehydration is going to take place. These are the conditions for dehydration, which is a type of elimination. So, but we need to know something. Here, in this case, we are going to use dehydration law, the law of dehydration, or Zaitseva's law. So when you look at this OH has to go. Okay. But you have to remember, according to the law of elimination, that we have two choices. We have choice of A and the choice of B one of them losing hydrogen. That hydrogen is the one which will combine with OH to form water. Remember, dehydration is loss of water. So what do we do here? You apply the law. The law says that during elimination, the hydrogen atom comes from carbon atom with the least number of hydrogen. Okay. So when you look at our hydrogen, or our carbon atom A, it has how many hydrogen? It has 3. And when you look at our carbon atom B, it has how many hydrogen? 2. So according to the law of elimination, it is B which is going to lose because it has the smallest number of hydrogen. Why is that one very important? It is very important because between the two which have lost, this gap is very important. Between the two which have lost, that's where the double bond is going to be established. So what do we have here? We are having CH3, and this one is CH because OH is gone. Then you have the double bond. This one has lost H. Then we come to CH3. That happens to be our product. And what is the name of the product? This one is symmetrical, so you can start counting from either side. So if you start from here, you're going to say 1, 2. And 1, 2 means that it is 2, 1, 2, 3, 4, 2 butene. Okay, if you are used to the other method, we can say it is but 2 in. Yeah, that's the reaction taking place to produce our alkane. Then comes the next question. Okay, then comes this question. It says, write the UPAC name and the condensed structure formula of the position isomer or of the alkene C. Okay, so this is the alkene C we are talking about. This is C, so this is what we are talking about. And from our question, now we know it. It is this one. Now, what is the position isomer of this alkane? And the question is, what is a position isomer? So a position isomer is a compound position isomers are compounds having the same molecular formula but different positions of either functional group, side chain, or substituent on a parent chain. I repeat, they have the same molecular formula, but they differ in the positioning. That position might be of the side chain, it might be the position of the substituent, or the functional group. For this case, it's a straight line. We don't have the side chain, we don't have a substituent. So the only position we can change is the functional group, which is the double bond. Now, when you look at this molecule, we're having our double bond here. What are the alternatives we can have for the double bond? There are 2 alternatives. We can shift it here, or we can shift it there. But guess what? Both of them are going to give us the same product. So let us construct the position isomer. So if we take this one, it's going to be CH2. Remember, the covalence of carbon must be satisfied. Each carbon atom must be surrounded by 4 bonds. So that's that. What do we have here? We are having CH. Because here 1, 2, 3, 4. 1, 2, 3, 4. Okay, what comes next is going to be CH2, and then lastly CH3. Okay, this is the condensed structure formula of the positional isomer of our product. So what is the UPAC name of this one? The UPAC name is 1-butene, or you can say but 1-ene. So those are the sample questions so far we have looked at. We are going to close this video here, and we call this one part 1. We are going to have a series of questions on this one so that we can exhaust it. So don't hesitate to go to part 2, which we are going to record now. So after seeing part 1, make sure that you go to part 2. Thanks very much. The channel is PSSB, Physical Sciences Silver Bullet, and it's Richard. So thanks for subscribing. If you have done so, if you haven't yet, please do so. We appreciate your time. Bye bye. See you in the part 2.